This table shows the weight of some fruits and vegetables. Complete the table. So they've told us that 3,500 grams is the same as 3.5 kilograms. And that makes sense because we know that there are 1,000 grams in a kilogram. So to change grams into kilograms, we divide by 1,000. And the easiest way to do that is to imagine our decimal point at the end. And then we can divide by 1,000 by moving it 1, 2, 3 places. And that gives us 3.500, which is the same as 3.5. Because remember, we can ignore zeros if they're on the end of decimals. Now they've given us 1.2 kilograms and we need to change that to grams. So we need to multiply by 1,000. The easiest way to do that, if we have a decimal, is to write zeros on the end so that our decimal has 3 decimal places, 3 digits after the decimal point. And then we can just ignore or take out the decimal point. So that's 1,200 grams. And that makes sense because if 1 kilogram is 1,000 grams, 1.2 kilograms is going to be just a bit more than that. Now we have 250 grams. We can put the decimal point here because remember, if the decimal point is at the end, we can move it 1, 2, 3 places. But now we need a 0 before our decimal point. So that's 0.250 or 0.25 kilograms because we can ignore zeros on the end of decimals. And finally, we have 0.03 kilograms. Remember, we can put a 0 on the end so that it has 3 digits after the decimal point, and then we can ignore or take out the decimal point, so that's 30 grams. The other way of dividing or multiplying by 1,000 is to write the number out. So for this question we had 1.2 and we needed to change to grams, so to multiply by 1,000. So we could copy down the decimal point. When we're multiplying, the digits move to the left and 1,000 has 3 zeros, so we need to move the digits 3 squares. We can move this 1, 2, 3 squares, do the same with this 2, and then because we have empty squares before the decimal point, we can write in zeros, and that gives us 1,200, because if the decimal point is at the end, we have a whole number. Then we had 250 grams, and to change that to kilograms, we divide by 1,000. Because we have a whole number, we can write the decimal point at the end, copy it down, and then move the digits 3 squares to the right. We have an empty square for our ones, so we can write a 0 in that, and we get 0.250. Then we had 0.03 and needed to multiply by 1,000, so we copy down the decimal point, move the digits 3 squares to the left. Then we can write a 0 in our empty square, and that gives us 30, because now the decimal point is at the end, and we can ignore zeros at the start of a whole number. Rebecca has rectangular tiles like this. She makes a larger rectangle using 4 of the tiles. What is the area of the larger rectangle? So the area is how much space a shape takes up. And with rectangles, we find the area by multiplying the length and width. So 20 times 10 is 200, which means the area of one tile is 200 centimeters squared. But here we have 4 tiles. So if we multiply the area of one tile by 4, 4 times 200 centimeters squared is 800 centimeters squared. So that's the total area of the larger rectangle. The other way to solve this question would be to work out the length and width of the larger rectangle. So we can see that the width will be 20 because one width is 10 and we have two of the smaller tiles. And then the length will be 40 because 2 times 20 or 20 plus 20 is 40. And then if we multiply 40 centimetres by 20 centimetres, again we get the same area. We get 800 centimetres squared. Join the dots to draw a rectangle that has an area of 20 centimetres squared and a perimeter of 18 centimetres. So the area is how much space a shape takes up, so how much is on the inside of the shape, and the perimeter is the total distance around the outside of a shape. So we want a rectangle with an area of 20, and we know that to find the area of a rectangle, we multiply the length by the width. So what times what is 20? Well, 20 times 1 is 20. But if we have two lengths of 20 and two lengths of 1, that will make a perimeter of more than 18. That will make a perimeter of 42 centimetres. Now we could have 10 centimetres and 2 centimetres. 10 times 2 is 20. But if we've got two lengths of 10 centimetres, that's 20 centimetres, and two lengths of 2 makes 4, so that would have a perimeter of 24, not of 18. So what else can we multiply to get 20? Well, 5 times 4 is 20, and if we have two lengths of 5 centimetres and two widths of 4 centimetres, that gives us 18 centimetres as our perimeter. So we need to draw a rectangle that has a length of 5 centimetres and a width of 4 centimetres. Jamie draws a triangle. He says, 2 of the 3 angles in my triangle are obtuse. Explain why Jamie cannot be correct. So we need to remember that angles in a triangle must add up to 180 degrees. But obtuse angles are larger than 90 degrees. So if you have two angles which are larger than 90 degrees, you will have more than 180. But there can't be more than 180 degrees in a triangle. So a triangle can only have at most one obtuse angle. You can't have a triangle with two obtuse angles because that would add up to more than 180. This shape is made with two cuboids. Write how many small cubes there are in this shape. So if we look, we have 4 rows, and in the row at the front we can see that there's 4 cubes. In the next row there will be 4 cubes as well. In this row here we have 2, 4, 6, 8 cubes, and 8 cubes in this row as well. So we have 8 plus 8, so 16, plus 4 is 20, plus 4 is 24. The other way to work this out would be to work out the volume of the cuboid if it were complete. So we would have 4 times 4 times 2, but then there are 8 cubes in this bit here that are missing. 4 times 4 is 16, times 2 is 32, minus 8 is 24. This chart shows the times when 5 children were at a swimming pool one afternoon. Who was the next person to arrive after Stefan? So we have a bar for each child, and the bar starts at the time when they get to the pool, and then the end of the bar will be the time when they leave. We need to know who was the next person to arrive after Stefan. So if we find Stefan's bar, it starts here, and then the next bar to start is Lara's bar. So she was the next person to arrive after Stefan. Now, who spent the longest time at the swimming pool? That's the child with the longest bar. So Grace spent the longest time at the swimming pool because her bar is longer than any of the other bars. We could work out the exact time in minutes that they spent at the swimming pool. So we can see that Lara got to the pool at 4:15 and then left the pool at this time, so slightly closer to 5 than to 5:15, so left the pool at 5:05, which is a difference of 50 minutes. For Amir, he got to the pool at 5:45 and left at 5:25, so that's 40 minutes. Stefan got to the pool at 4:10 and left at 4:55, so that's 45 minutes. Grace got to the pool at 4:20 and left at 5:15, so 55 minutes. And Tom got to the pool at 4:30, left at 5:15, so that's a difference of 45 minutes. So Grace spent the longest time at the pool because she was there for 55 minutes. Here are 3-digit cards. We have 1, 5 and 6. Choose 2 cards each time to make the following 2-digit numbers. The first one is done for you. So 56 is an even number because even numbers are multiples of 2. So numbers that end in 0, 2, 4, 6 or 8. Now we need to find a prime number. And a prime number is a number with only 2 factors. A number that's only in the 1 times table and its own times table. So we can't use the 5 as our ones digit because any number that ends in a 5 will be in the 5 times table, will be a multiple of 5. And we can't use 6 as our ones digit because if a number ends in 6, it's an even number, so a multiple of 2. So we know that the 1 will need to be our ones digit, and then we need 6 as our tens digit to give us 61. 61 is only in the 1 times table and the 61 times table. It doesn't have any other factors. Now we couldn't use 51 because 51 is a multiple of 3. If we divide 51 by 3, we get 17. We don't get a number with a remainder. So that tells us that 3 and 17 are also factors of 51. So its factors are not just 1 and 51. Now we need a common factor of 60 and 90. So a factor is like the opposite of a multiple. So we need a number with 60 in its times table and 90 in its times table as well. So we can make the number 15 because 4 times 15 is 60, so 15 is a factor of 60, and 6 times 15 is 90. So both 60 and 90 are in the 15 times table, so 15 is a common factor of 60 and 90. And finally, we need a common multiple of 5 and 13. So a number that's in both the 5 times table and the 13 times table. We don't have a 0-digit card, so that means we'll need to use the 5 as our ones digit because all multiples of 5 end in 5 or 0. So we can have 65 because 13 times 5 is 65. So it's a common multiple of 5 and 13 because it's in both the 5 and 13 times tables. A and B are 2 chain wheels on a bike. For every 2 complete turns that wheel A makes, wheel B makes 5 complete turns. If wheel A makes 150 turns, how many turns will wheel B make? So we know that for every 2 turns for A, we have 5 turns for B. And we also know that wheel A will make 150 turns. So we need to think 2 times what is 150? Well, if we divide 150 by 2, we get 75. So 2 times 75 is 150. So to work out the total number of B turns, we need to multiply by 75 as well. So work out 5 times 75. We can use short multiplication, and that gives us 375. So that's how many turns wheel B will make. Now, if wheel B makes 90 turns, how many turns will wheel A make? So here again we have 2 complete turns that wheel A makes for 5 complete turns that wheel B makes. But this time we're told that wheel B is making 90 turns. So this time we need to think 5 times what is 90? Well, if we divide 90 by 5, we get 18. So that means 5 times 18 is 90. So we do the same to the A turns, and 2 times 18 is 36. So our answer is 36 turns.